Two are going to be in the same class. I mean, he might be in the same room.
This makes me happy. So what I did you guys give me an average? Give me an average? No. We're just going to wait for you to come back and do it. So if you were crunching it manually, like we did before, -8 times 1 plus -7 times 1.
That's 15.
Plus negative, that's okay, tell me we're to come back to that. Okay, plus, and you have to go all the way through all the options until you got to 8 times 1. Okay? And then you'd have to divide, that would tell you, what that would tell you was, if I took all the winnings you guys had in the class and put them into a big pile, that's how many would be in that pile. Does that make sense right now? If I do that arithmetic, that top, that means nobody has their pile anymore. We now have one big communal pile all the winnings go into. Now, of course, some of those are negative, which means that some of the positives will be knocked down to balance them out. But that's what that number would represent. Then we'd have to take that and evenly distribute it to each person in the room, which would be the sum of this column, how many people are in the room, yes? So 1, 2, 3, 4, 5, 8, 17, 18, 23, 28, 29, 34. Is that correct? Did I do that right? So you have to divide that by 34. Now I showed you a trick in class, I think it was last week, using 1-bar stats. I'm going to do that real quick, just to get the number really quickly. If you want to see this again, you have 2 options. Number 1, you go watch the video from last week. Number 2, take Math 243. We do it every day. So just not a plug for the class. I know a bunch of you take it in anyway. So I'm going to use that quick trick to do the math for me. Okay, just to get the number. Just to get the number. I don't want to get hung up with it. You can obviously do the arithmetic. You've done it many times before. So I'm going to do 1-bar stats on list 1 and list 2. I get an average of 0.56. Well, that's close enough. Hey, close enough. We're going to call it 0.5. And it's 34. That's how many people were in the room, so I'm happy with that. I can live with that. So this average, your guys' average winnings. So this is answering, I think, question number 3 on the quiz, yes? I think this is answering question number 3 on the quiz. Your average winnings are just about a half a starburst per game. Let's go to Vegas.
Oh yeah, brother.
Let's go to Vegas, hell yeah, sister. Why should we go to Vegas?
Because you're going to win.
Because that number is positive. Remember all these negative numbers? What this positive number right here means is, whatever negatives there are being canceled by the positives. So all we got to do is go to Vegas and keep playing. And we're going to win on average. We'll say, wait a minute.
It's going to be due.
Wait a damn minute. Well, what's on your mind?
What if we cut out 7 and 8?
What if we cut out the outliers? Should we also cut out the positive 8 down there? No, only make it look better. You got a future in government, Ian. You got a future in government, brother. Go, Michelle.
To get those odds, all 34 of us would have to be there.
Good. Now, I want to. Thank you for that. That was a beautiful segue, by the way.
It goes down.
I couldn't have done it myself. Here's the deal. Here's the deal. See, the problem is there's 2 problems. There's volatility amongst individuals, and there's also volatility amongst the long run. You guys, 34 of you played 10 games apiece, which means we've now seen 340 total games. Honestly, that's not all that long of a run when you think about Vegas. What we just saw here would have happened probably in 2 minutes at one casino in Vegas, even half of one casino in Vegas, half the craps area. So what we'd like to do is to kind of see it on average over time for the entire thing. But I want to come to one question at a time, First of all, our average winnings are just about half a starburst per game. Starburst. So this is the answer to question number, I think. Let me look at where that is.
3.
Yes! Question number 3. How do we do as a class on average? On average, it's essentially like this. I'm up here with my bag of starbursts and a kitchen knife. Every time you guys are getting ready to play around, you don't bet the ante, but I take a starburst and cut it in half and just hand you a half. Because that's what that says, really. This means on average, you win 1/2 a starburst per game, which means you keep your ante and I just hand you a half a starburst. That's what it means to average half a starburst per game. It's not negative. Negative would mean I have to take one away from you. But it's positive 1/2. This would be the equivalent of walking into the casino, knowing this number, and walking up to the casino boss and the boss goes, put your chip down. I'm like, better yet, you just give me half a chip. Because that's what that means. On average, over time. Now, does anybody see a problem with that happening in Vegas? Carrie?
Yeah, they're gonna bet.
Don't always bet one.
Well, good. You're absolutely correct. Absolutely correct. They can bet more than one, which would make this go up by a multiple. So for example, suppose you bet 2, your average will be 1 starburst. If you bet 4, your average would be 2 starbursts. It would multiply the average. It's a 243 question. Very nice. It's actually a Math 243 question. If you multiply each data set by a multiple, the average is also multiplied by that. So if you bet 10, you'd average 5 per game.
We know that when we lose it gets
Now,
ugly and the more people are playing.
what Carrie and Michelle are hinting, I think Will was hinting at it about 20 minutes ago too, is there's something fishy about this. This is not right for Vegas standards.
Yeah.
Because Vegas would bankrupt themselves on this. Because think about it, if your average is positive, that means their average
It's negative.
has to be negative to pay for your average being positive. So there's something wrong here.
Maybe we didn't have enough data.
No. Well, we didn't have enough data. That's the whole point. Is 340 is not 340 is not long run-ish enough. So for example, question number 4. I ask you guys, what's the probability of our winning on a pass line bet? So here's what I want to do. I know that we played 340 games, right? I know that from that number. Let's do a real quick. Sorry, I did it right over you. What's the probability of us as a class winning? Now I know we played 340 times. No disrespect to Faith whatsoever. We're not doing this theoretically, we're doing this experimentally. So what I want you guys to do is look at your data again. Look at your data again. Raise your hand, and with a number of fingers, show me how many times you won in your round that you played. Does that make sense, what I just said? So raise your hand and show me with fingers how many times you won out of the 10 games you played. Out of the 10 rounds you played, how many times did you win? Let me go around real quick. I'm going to make a quick little, I'm going to cheat, use Excel, I'm going to use TI again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
That is if Excel works.
Actually, I got a better idea. I guess it's going to be easier for me. I apologize. How many won no times out of the 10? No times out of the 10? 1 time out of the 10. 2 times out of the 10. Oh, you won 1. I'm sorry. Thank you. 2 times out of the 10. 3 times out of the 10. Okay. 1, 2, 3. 4 times out of the 10. 1, 2, 3, 4, 5. 5 times out of the 10. This is going to be the biggest, right? Because of that 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's a 9. Okay, I can probably get some of this from behind me. 6 times out of the 10. 1, 2, 3, 4, 5, 6, 7. 7 times out of the 10. 1, 2, 3. Raise your hand. 8. I don't think we had 1. We did have 1. That's right, Joanne. And then no 9s and 10s, correct? This is a very fun distribution. We'll play with this one in Math 243 quite a bit. I'm going to run a real quick calculation, if it's okay with you guys. L3, L4. We have 148 wins. We have, did I do that right? 148. No, something's wrong. Something's wrong. That should be 34. 34.
Five people left.
Oh, shit. Well, we're screwed. We're screwed. Well, but there should be 34 here.
Isn't that paper right there? It's right there. Is it?
You know what? It doesn't matter. It doesn't matter. Here's the point. Here's the point. It almost looked like this game was completely even. Because when you looked at our winnings, our average winning of 0 was the most common. If that were the case, if profiting 0 were the most common, what would the probability of winning this game be? If you think about this, if you won as much as you lost, which is how you would end up back at 0, correct? Just like I did in my example, I won some and lost some and ended up back where I started. What would the probability of winning, therefore, appear to be, Faith? Wouldn't it be 50-50?
Yeah.
Wouldn't it be 50-50? So theoretically, 340 should be under what number if it were 50-50?
170.
Would it have to be 170? So in other words, of the games we played, we should have won 170 and lost 170. But if that were the case, that means that our average would have been 0, because we all would have canceled back to 10. So did we win more or less? We must have won more. So what I'm going to do, we're going to make a little Sean math here. It's clear to me that our probability of winning, we must have won more than 170 games out of the 340, correct? That's the only, unless you guys cheated somehow I wasn't looking. That's possible. I am ADD. But the only way that we could have profited in this game, the only way this could have happened, is if you guys won more than 170 games. Because that means that distribution is higher on the positive side than the negative side, and the only way to be higher on the positive side is if you win more. So, I don't know exactly what the number is, but I know it's bigger than 1/2. It's bigger than, let's put 1/2 here. And please realize the difference between that 1/2 and that 1/2. This is a percentage of time that we win the games. That is a number of starbursts that we win. It just so happens that's a fractional number of starbursts. That happens sometimes. I still call BS on this. Because Vegas would never do this. This is a death sentence for Las Vegas, right? They pump water from the Colorado River to a tiny little town that is 0% humidity. What is the only way they could possibly do that? By taking your money. That costs a lot of money. Where does it come from? You've seen the cartoon? I think I told you about it.
No.
Welcome to beautiful Las Vegas. Generously paid for by those who are bad at math. You never seen that?
Nope.
Well, you should have. I did tell you about it last time. I know I did. And I don't remember anything. I remember telling you that. Faith, go.
Can Vegas just bank on that that's a small enough payout that people get greedy and so they start betting on the other ones?
I love this. Oh. And what you're talking, so what Faith just said is the actuary's job in Las Vegas. They have to know the odds of winning, and they can adjust the payouts accordingly. You guys just saw this on, if you did the quiz on betting on, whatever it was, betting on fives, you did this. You saw how you can mess with the payouts quite a bit and still make the averages negative for the player. So Vegas knows how to do that, and you're going to learn how to do it for a pass line bet right now. The first thing we have to do, is answer question 5, which I believe, so for that pass line bet experimental, to answer that one, just put greater than 1/2. Number 4, I'm going to grade these anyway. I'm going to grade these for you, because I don't know where Emily is right now. So just put greater than 1/2, because I can't actually get the data, but I know we know it has to be bigger than 1/2, because you guys couldn't have made money otherwise. My argument is that Vegas would never allow that to happen. Not with those payouts anyway, right? What they could do is they could mess with the payouts. They could only pay you half out versus 1, and that would take care of the winnings maybe. But then you wouldn't play. Wait, when I lose 1, but when I win 1/2? Screw you, I'm going to go play roulette or something else, right? So I hear what you're saying, Faith. But Vegas also has to have the psychological crux of making sure somebody wants to play the game. So what I'm about to do now is we're going to do some pretty